Okay, in this tutorial we're going to talk about stateful firewalls, and in particular we're going to talk about CBAC, or context-based access control, which is a Cisco firewall technology, a stateful firewall technology. Now, what is a stateful firewall? A stateful firewall is able to track network connections or conversations crossing the router, and it can see if these network connections are good connections, and if they are, if they're connections that were requested from within the network, it will allow that traffic to come back through the router. So it's able to actually look at the packets that are crossing the router to examine to see if this is a good request or if it's just an intruder from the outside trying to get in. And if it's a good request, usually it's been initiated from within the network. And so a stateful firewall will be able to look at that information in those packets and say, yeah, this has been requested, so we're going to let it back through the firewall. Okay, so CBAC, or context-based access control, CBAC, is one of the more advanced Cisco technologies for stateful firewalls. And we've looked at a few so far. In previous tutorials I've talked about TCP established ACLs, which looks for control flags in the TCP segment fields like ACK. We've looked at reflexive ACLs, which was an improvement on the TCP established ACLs, which is another form of kind of a stateful firewall technology. Reflexive ACLs looked at the control flags like an ACK or a SYN or a reset or a finish statement or flag in the TCP fields, right? And to see, hey, is this conversation already been established? Has a three-way handshake taken place, and somebody's requested some information, and an established session is happening, so we'll allow this traffic through. Reflexive ACLs also looked at source and destination addresses. It can look at the port numbers, and it can create temporary ACLs, or ACEs as they're called, to temporarily allow that traffic back through the firewall. Now, CBAC, or context-based access control, can do this and more. So CBAC, or CBAC, context-based access control firewall, is a stateful firewall that can look at the TCP connection setup, the control information, and the flags. It can also track and monitor UDP sessions. All right, reflexive ACLs didn't do as well with UDP because there's no control flags in there, no port numbers. Well, there's port numbers, but no control flags. And so even though reflexive ACLs dealt with UDP, it didn't deal with it as well. With context-based access control, there's things that you can do that you can't do with reflexive ACLs, or at least I wasn't able to do with reflexive ACLs. So UDP session information, it can look at, inspect, and monitor TCP sequence numbers. It can track the sequence numbers. It can look into DNS queries and replies. It can look at ICMP message types, so different protocols, right, like ICMP. It can look at the application layer and applications that rely on multiple connections, like multiple UDP dynamic port ranges that it wants to open up. Programs that do that are like FTP, wants to open up a multitude of UDP ports to transfer files. And CBAC can track that and then allow that traffic to go across. I was not able to get that to work with reflexive ACLs. So TFTP, FTP, and multimedia applications that rely on multiple connections. It can also look at embedded addresses. So if IP addresses are being NATed or changed as they cross the router, it can look at that for NAT and port address translation. And it can look at application layer information as well. So as you can see, there's a lot to a CBAC, or context-based access control. So what we're going to do is we're going to set it up on a network that looks a lot like this. So if we look at this picture, the CBAC, or context-based access control, works similarly to the TCP established and the reflexive ACLs, in that what you want to happen is you want to temporarily allow traffic to return that is going out, basically, or leaving the private network, you want to allow it to return, right? But you want to block everything else. So only traffic that has been generated from inside the network will be allowed to return. So CBAC is a stateful firewall. It inspects the outgoing traffic, so it looks at traffic that is coming into the interior interface, right? In this case, fast Ethernet 0.1 on the inside. So it's going to inspect traffic that's coming into this interface, which is destined to go out of the network, right? And it's going to examine that. And if it sees a permit, then it will create a dynamic ACL or a dynamic access list to allow the traffic to return from the outside in. Right? So essentially what you want to do is you want to allow the traffic out of the network, and you want to block traffic coming into the network so that only the traffic allowed in is allowed in with this dynamic ACLs, so dynamic temporary permit statements that are created on the fly by the router by inspecting the outgoing traffic and then allowing a temporary permit statement or ACL access list to allow that traffic through. But everything else from the outside in is blocked. So anything that's requested from the outside is blocked by default. But if it's been requested from the inside, it's allowed to return with this temporary ACL. So how do we do that? Well, you have to create two ACLs. You have to create an ACL on the inside of the network that's going to do the inspecting, and then you're going to create another ACL on the outside that basically blocks everything by default, or almost everything. So in this scenario, we've got a 192.168.1 network over here. Our host will be this computer right here at 192.168.1.100, and it's going to request ICMP pings and echoes. It's going to request web pages using TCP port 80, right? A web page request. And it's going to make try to do a TFTP file transfer, so using the UDP protocol, right, on port 69. So we're going to test this out with UDP on port 69, with TCP on port 80, and with ICMP echo requests. On the other side of the network, on the outside, we're going to have a web server on this router over here, and we're going to have a TFTP server on this computer over here. And this will be on the 3 network at 3.100. And this web server will be over here on this router, right? And of course, this inside network is going to be the 192.168.1 network with host 1.100 and the router at 1.1. And we're going to configure this right now.